Hey, Mr. Lawrence, ẹ bọ̀ mframa paa o.
Hello, uncle. Hey, it's
Hello, hello, hello. Please, can you hear me?
yes,
Yes,
please.
please.
Please, good afternoon.
Yes, sir, we can hear you. Good
Um,
afternoon.
please, I've called the tutor and then he said he wasn't having a good connection, so he's heading towards his office to join the class with us. So we should expect him in about 10 minutes.
Okay,
Okay.
thank you.
You are welcome.
Hello. 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 Hello.
Hello.
Hello. Hello. Hello. Hello. Hello. Good afternoon to everyone.
Good afternoon, sir.
Hello.
Good afternoon,
how,
sir.
yes. Please, how are you doing?
Yeah, okay.
Fine,
Okay.
sir.
Okay, please. I'm sorry for coming late. I think it was not communicated to us early. So sorry for that. Are you still waiting for some students to join, or we have all joined? Please, can you hear me? Hello.
We can hear you very
Yes, sir.
clearly.
Yes,
Please, can you all hear?
Yes, sir.
So we can hear you, but your voice is very far. It's kind of
My
faint.
my voice is very far. Is it okay now?
Actually, it's kind of
Okay.
faint.
Okay. Sure. Now, is it okay? Hello, is it okay now? Is it okay? Okay.
Yes, sir.
That,
Yes, sir.
yes, okay.
Thank you, sir.
Okay,
Yes,
okay.
sir.
Can we all
Thank you
hear
very much.
me when I talk?
Yes, sir.
Okay, okay, okay. That's good. That's good. That's good. Please, my name is Francis Okontum. I'm going to be your course coordinator for computer hardware. And as you all know, this switch code program is it entails a lot and it's highly compact. And we are going to do some 4 or 5 weeks to finish a whole lot of data. Consider that using 3 months and going to have 4 months to finish. So we have to do a lot of reading ourselves. But when we meet, we'll be able to explain, but we can't go extensively because we want to cover a lot too. Basically, this is computer hardware, and I know most of you are other teaching mates in your schools or wherever you find yourself. You are also in that business, right? So it's not going to be anything difficult. Because some of the things that we are going to mention today or today ongoing, I think most of the things you know it already, but as part of the course department, we are supposed to teach it. And it's not going to be anything difficult. So please, you have to read through your mind to suit whatever you're going to do. It's just an academic work, academic exercise that we are going to do. As the lecture goes on, if you have any question or any submission, anything that is bothering you, please, you can just interject. Maybe say, I have questions, we will allow you. Maybe if you want to have something that you want to share with us, so that we can also get more. You are welcome. We are in the university, we are here to learn together, not the only one. So you can learn from your friends. I can also learn from you, and you can also learn from you too. So let us, without wasting my time, I want to share the course outline. Have they given the course outline to you? Hello, please, do you have the course outline?
No.
Not yet, sir.
please no.
Not yet, sir.
Yes, sir. Okay. Thank you. So please, I'm going to share the course outline with you, like for you to see what we are going to do any other week. After this, the course rep should just call me. I will forward it to you and we'll make it available to all the students. Once you have the course outline, you are ready to go. I also give you the course materials, the PowerPoint slides, and some commercial A plus book. That's where I prepared the slides from, so you can read the slides alongside the commercial A plus book, and it will be very, very fine. Once you go through that material, then I can assure you that you are ready to get an A for the exams and the quizzes and all that. So let me see.
Sir, please the site again.
You said what?
Please
You
the
said what?
site again where you prepare the slide.
You said I should share the slides or what? I didn't get what
Sir,
you
you say
said.
you prepare the slides from a site so we can read it. So I'm asking if maybe you can
It's not from a
re-mention
site.
the.
It's, uh, it's not from a site. It's from Comshare A plus. That I will share that PDF with you. That's what I said. I said I will share the PDF. That particular book. I will share it with you.
Okay.
So don't worry.
Okay.
I'll share it with you. Okay. Please, can we see the course outline? I've shared my screen. Can you all see it?
Please. Yes,
Yeah.
please.
Yes, sir.
Yeah, that's it. So that's the course outline. After this, out the course work. So if you look at the first week, I will not get time to go through this, but maybe let's go through some of the things that we are going to do. So if you look at the first week, what are you going to do? What are you doing? We are going to look at an overview of what system components. So as usual, as we all know, we will still define what the computer is. Then we also look inside the box. That's we will try to take a system unit or a computer from system unit. Then we go into it and try to identify some of the various or components that we have in the computer. Then after that, we can also check outside the box, that outside the system unit, some of the various hardware devices that we can see over there. So basically today, what we are going to do is try and make some basic identification of what the basic hardware components that we have in the computer. So that's what we are going to do today. And the second week too, we also look inside the box. That's we are going to take one of the components, like maybe the motherboard. Then we will talk extensively about what the motherboard. Maybe we also take the processor. Then after taking the processor, we will also try to elaborate, talk more about what the processor is, what the computer processor is. So then from there, you take the computer memory and so on and so forth. So we are going to do a whole lot of things. And we also look at what maybe the BIOS, what the BIOS, the CMOS battery, and so on and so forth. So basically, this is the course outline. I think you know, I'm going to share it with the course work. So please make sure you get the course outline, because this one is going to guide you, and maybe in what it's going to guide you if you want to learn, so that you will not learn how to, maybe you will learn according to what the course outline, because we are going to set the exam questions to you, set the questions based on what the course outline. Then we can also take outside the system unit, that's outside the board, that's the system unit. You describe some ports, cables, and some connectors. Try to also identify how to install most of the things, multimedia devices, installing and configuring what output devices, and so on and so forth. Then we come to maintenance and what troubleshooting. Once you have done computer hardware, at least you'll be able to know the basic troubleshooting skills that you are supposed to know. Maybe if you are called upon as an IT guy in any institution, wherever you find yourself, and maybe the computer or the laptop is facing some problem, you should be able to troubleshoot and know what exactly the problem is, maybe before you even give it to a technician to work on it for you. So basically, once you have done IT, you should be able to know some basic troubleshooting of skills. Maybe if you have a desktop and you are trying to boost the desktop and it's not responding, as part of the booting process, you get to some point and it terminates. Then you hear some sound, that one should tell you that problem is coming from the memory. The memory is not well seated in the memory slot. So as a hardware guy, you should be able to know some of these basic things. Then at some point too, whether the computer has been able to go through the booting process, it has been able to check what the basic input and output devices before a computer can be put on. It should be able to go through the BIOS system and do the basic input and output check to see if everything is connected. Sometimes if the keyboard is not well connected, at some point the booting process will terminate. So if it terminates, you should be able to know that the problem is coming from the keyboard, or that the problem is coming from the monitor, or it's coming from the memory, or any other device that is connected to it. So please, this is just basic troubleshooting skills that we also know. We also, at some point, take the operating systems and talk more about it. So basically, this is the course outline. Please, I can't go through everything. I will share it with the course where please take your time, get it, and use it as your learning guide. All the questions that you will see, whatever exam that you are going to write, and everything is going to come in the course outline. Maybe you cannot set any question outside the course outline. So as a student, the first thing, if you're in the university, that you're supposed to get is get the course outline from the lecturer. Once you get the course outline and you get the materials, you are ready to go. Please. Then, as I said, I'm going to share with you some CompTIA A+ certification all in one for the dummies. It was written by John Willie and Sons. It will go through it and it will also be well with you. Any question at the moment? Any question? This is the course outline. So, as I said, and this course is also going to provide you a comprehensive overview of what computer hardware and its functions. It also covers what the various components of the computer systems, and it also the most of the components of the computer system includes what the input and output devices, the storage devices, the motherboard, as I've said, it also include the processors and the memory modules. We also talk about the power supply. So these are the basic input, basic components of what the computer and many. So as a student, that is required of you. You want to learn how to identify and troubleshoot the hardware problems. You should also be able to upgrade and install some of the hardware components, and also try to optimize what the computer performance and so on. So this course is also going to explore some other emerging hardware technologies. And some of these emerging hardware technologies that we talk about is the virtual and augmented realities. Sometimes we are now in the artificial intelligence era, and if you go further, we are also talking about quantum computing. Before you can do all these things, your knowledge in computer hardware should be very, very sharp, and it should not be shallow. And furthermore, it's also going to talk about the impact of hardware on computer security. And also, I think that students will also gain an understanding of how hardware vulnerabilities can also be exploited by malicious actors. At some point, we are going to talk about one in terms of computer security. If your hardware, there's one part of the computer hardware, if it's not functioning very well, it's having some problem. And sometimes you don't go to the BIOS and enable it or disable it. Hackers can hack into your computer using that part. So we want to look at that part when we get there. And we are saying that the course will also cover environmental concerns associated with computer hardware. That's including e-waste and sustainable design principles. That at some point we talk about it's how to work. And if you have a computer and it's spoiled, and how you are going to dispose it. And there are some processes that you are supposed to follow. But in Ghana, our country, we don't have that guidelines. You see these people going around to the scrap dealers, pick these computers, and they go and burn it and expose it to the environment, and it is causing more harm to us than good. So maybe you have a hardware device, how are you going to dispose it? So we are saying that by the end of this course, the students will also be able to apply their knowledge and skills to build and maintain computer systems and contribute to the development of future hardware technologies. So please, it is fully packed, and we are going to do it. We can do it. And some of the seniors have been able to do it, and they got A's, the B classes, and the B's and the C's and other grades. So please, depending on whatever you want, you have to put in a lot of effort by learning. Once you put in a lot of efforts, and I don't think you are going to fail, you are going to pass with a better grade. That's A, the B classes, and so on and so forth. Okay, so please, that is the course outline for you. Make sure you get it. And I know some students will don't forget about it. Get the course outline so that it will guide you and in your reading, so that you know to read any other material according apart from whatever you have on the course outline. Okay, please, any questions so far? Any questions so far? Any question? Can you hear me? Am I going fast, or is it okay?
So it seems the speed.
We can hear you.
Yeah.
You said it is what?
The speed limit, no?
I'm going fast.
It seems it's 2.0.
You said what? I'm going fast.
Yes, if we can reduce the speed limit.
Okay, sorry, thank you. I accepted there. If there's anything bothering you, please, we are in a class, let's share it. So I'll slow down a little bit. I was just trying to go through the course outline. But I think you all agree with me that we all have to get the course outline. Please, who is the course rep? in the course rep, in the course rep. Do you have the course rep or we don't have? Hello, please. Do you have course rep?
Please, we have.
Yes, please. We
Henry,
have.
You have a course rep.
So please,
Yes, please, I'm here.
please. Okay, please, Henry, I'm free on Gmail. Please reach out to me. Maybe you have my number so that I'll send the course out
Okay, sir.
and all the materials, the slides to you. When you get it, you have to also
Yes.
make it available to your colleagues so that everybody you all be at par. Okay, if we are done with that, then
Yes, sir.
we are going to start. We are going to start today's lecture, and it's on what computer hardware. Computer hardware. So what we want to do. So today we are just going to look at what an overview of what system components. That's overview of the. We are going to whatever we are going to do today is to try to identify the various components that we have in the system unit, the various components. So before we can learn anything about the motherboard, we should be able to identify what the motherboard is. Once we identify it, then we can learn more about it. You should be able to know what the menu is. So what do you hope to achieve after today's lecture? I said that we should be able to introduce what the basic components that make up the personal computer. That's we should be able to identify sorry, the various what components that we have. Then also try to identify the fundamental principles that apply to what personal computers. So these are some of the basic objectives that we want to achieve. And then, so basically, if you want to start, we will start by saying that what's a computer or something. So we are saying that in computer, we all heard about this right from the JHS level, the primary school, up to this level. We will still define it anyway, anyhow. We are saying that the word computer comes from the word what compute, which means
Hello, are you online? Yeah.
What's an opera? Opera have a plan.
Yeah, I'm not the only person who can hear anything. No.
It's like the lecturer is off. It's gone off.
Oh, okay.
I say that part of the maybe 20 next time. Look for me to do. Next time I will to them because we talk about community. You have to look. All of another one our channel.
Mr. Henry, can you call the lecture so that we know what we are doing, please?
Please, I'm calling him, so I'll get back to you. Hello, class. Please, I've been able to reach the lecturer. He says he's going to join us right now. He's changing his network from a different network to a new one, so he's going to join us right now. Thank you.
Please come again.
I have been able to contact him, and he says that he's going to join us right now. He was having a problem with his network, so he's switching to a new network so that he joins us.
Okay, thank you.
You're welcome, sir.
And it's all of system interface. Then the senior attach SCSI. These were the four major technology used to connect hard drive to what? A motherboard. Okay.
Classes, we can hear you.
We talk about the idea of cable. And the other
Hello. 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 Hello.
Yes, hello.
Hello. Good afternoon.
Yes,
Hello.
good afternoon.
Hello, sir. Good afternoon, sir.
I'm very, very,
Good afternoon.
I'm very sorry for that. Sorry. I was facing some network challenges in my house, so I have to drive all the way to the office. So I'm so but the internet service providers, they are always deceiving us. Yes, I've subscribed to the whole this thing that I've been deceived. So sorry for that. I have to rush all the way from my house to the office.
That is fine. That is fine, sir.
Okay, so we are going to continue from where we left off. I think you can hear me now. Can you all hear me?
Well, yes, sir, but then it's like your voice is a little bit far. If you could amplify your voice a little bit.
Okay. Is it clear now? Is it okay?
Yeah,
Okay.
very better, very better.
It's better now. Okay, that's please. What about the rest? Is it okay? Can you all hear me? The rest, can you all hear me?
Yes.
Yes, we can.
Can you hear what I'm okay? Fine. Then we are going to start all over again. So, like I said, you were just on. You are saying that the computer is what? It's an electronic device. It's an electronic device. That's what you said. And in simple terms, all computers are made up of what? Four basic functions. If you talk of computer, basically at the basic level, whatever level that you find yourself, it's made up of what? Four basic functions. And these four basic functions that the computer is having the capability to work, to do some data input and also give you some data output. That also give some data processing, and it's also having the capability to also store whatever data the computer will process. So that's the four basic functions of the computer. So in terms of the data input, the basic input device that we all know is the keyboard, which we all know. So at this level, I mentioned keyboard, computer keyboard, you should know. Then we also have the mouse and the scanners. We also have the storage devices. So the computer is also having the capability to store whatever information that it has been processed. So example, if we have the pen drive, we have the hard disk, we have the floppy disk, and the pen drive, the CD-ROMs, and so on and so forth. These are some of the basic storage devices that we have. Then we have the processing. The computer has an electronic device, also has the capability to process the information. And when we talk of processing, the basic component that can do most of the processing for us is the central processing unit. In short, we call it the CPU. The CPU. And when we talk of the central processing unit too, and we are saying that one will help you do the processing. And we have the output. The output is what is the monitor, the speakers, and the printers. So the computer is also able to also give you whatever out. So these are the 4 basic functions of the computer. So it gives you in terms of the input, we have the basic devices that will help you, the hardware device that will help you, the keyboard, the mouse, the scanner, and the card reader. Then in terms of the processing tool, we have the CPU, that is the central processing unit. Then we have the storage device, we have the RAM, the hard drive, the magnetic tape, and so on and so forth. Then the output too, we are also going to talk about the monitor and the printer. So these are the basic major 4 basic functions of the computer. This one we all know it already. So basically we are going to take the system unit and try to diagnose, try to look at the various components that we have in the system unit. So most of the processing storage capacity show up inside the system unit. So this session will give you will make you identify some of the basic components. So if you look at the picture over here, please can we all see the picture? Can we all see the screen?
Yes, sir.
So this is the system unit. We have opened it, and this in short, some people also call it the chassis, or others also call it the case. So can you tell me some of the components that you can identify over here, some of the hardware components that you can see? Who can tell me some? Whatever you see over there, just feel free and tell us.
The motherboard.
You see the motherboard. Yes, that one is true. The motherboard is there. What else? Yes,
the power
supply.
You can see the power supply. That one is true. What else can you also see? Yes.
The cooling fan.
You can see the cooling fan. The cooling fan. That one is true. What else can you also see? Yes. What else?
The memory slot.
You can see the memory slot. The memory slot. How many memory slots can you see on this motherboard? How many memory slots can you see? Yes. Who can tell me the number of memory slots on this motherboard?
4. I can see 4.
Yes, it's 4. You can see 4 memory slots. The memory slots are 4. Yes. What else? What else can you also identify? Yes.
Hard drive.
You can see the hard drive. That's the hard drive. Yes. And this hard drive, who can tell me, is connected with what cable? What cable? What are the cables that are connected to the hard drive and the other?
So I think it's the SATA cable.
SATA cables. The SATA cables. So gone were those days. We used to use what we have the IDE cables. Can you know the IDE cables? The album belt. Did you see the album belt cables?
Yes. We've seen that before.
Yes, but this computer is connected with a hard drive, and the cables that we have in this system unit is what we call the SATA cables. Okay. So what is the difference between the SATA cables and the IDE cables? Which one do you prefer? If you're going to buy a computer with IDE cables and the SATA cables, which one will you buy?
Yeah. So if I'm permitted to speak,
Please,
for me, so for me, I'll go in for the SATA because it appears to be an advanced form, serial advanced technology advanced attachment. I think that's the full meaning.
Yes.
So yeah, it is the latest, and then it's able to, I think, transmit data more faster than the ID. The ID usually it came with so many cables and is vulnerable to a failure, especially when one cable is fault. But this one is like it is integrated. So for me, I'll go in for the SATA. Yeah, thank you.
Yeah, please, thank you very much. You have done it all. Please, we are in a class, you should know this is the university. Maybe with my style of teaching, I allow students to share their ideas. I'm not the only one pouring the information. We have to all share the ideas. So at this level today, whatever we are going to do is just to identify them, some of the basic components that we can see in the computer. Please, that is true. So the SATA, whatever you said about the SATA is true, and it is the current technology now, and people are going for it. And now even the IDE cables, we cannot even see it in the market. That's the above belt. Most of the computers are not coming. They think that it is an obsolete technology. So the SATA is now, yes, what else can you also see? Please let us identify the various components. Yes, what else can you see? There are a lot, Yes. Please, I'm waiting for you to tell me what you see. Hello. Who's ready to talk?
Power cords.
You can see the power cords. That one is true. That's the power cord. Yes. What else? Yes. Oh, there are a lot of components that can be mentioned. Yes. Please
The CD or DVD drive.
You can see the CD or the DVD drive or the optical drive. That is true. Yes, that is true. Yes. What else? Don't raise up your hand. Just talk if you want to talk. Because this thing is on full screen, so I can't see you when you raise up your hand. Just talk. Once I'm lecturing, if you have a question, just say, please, I want to ask a question. That's all. Don't raise up your hand. I will not get up and go and look at that place.
We can see the CMOS battery.
The CMOS battery.
The CMOS battery.
Yes, sir, you are seeing right. You are seeing right. You can see the CMOS battery. Yes, what else?
Okay, I think the integrated circuits too are there.
You can see the integrated circuits on the motherboard,
yes.
right?
Yes, on the motherboard, exactly.
That one is true. Yes, what else? Let's mention it. There are a lot that we can mention.
Power supply.
You can see the power supply.
I can see the power supply.
Please, that one is true. What else? Yes. We cannot see the processor because the fan is on the processor, but once we see the fan, then we can see that there is a processor over there, and the fan is always on the processor. That one is true. Yes. What else? I have also told you what I can see.
The
what else can you see? You can
the
see
memory slots.
The memory slot, and we have 4 of them on the motherboard, and so on.
Sir, please, just for a quick question before we just move on from that page.
Please ask your question.
Yes, you just stated. Yeah, you just stated that the fan is usually underneath the CPU. Is it all the system units that has that?
The processor
like
is
I've seen some
under
cases.
It is
the fan.
The processor is under the fan. It's not the fan is under the processor. No.
Yes,
you
yes.
understand.
So my question is it? Yeah, I got it. Maybe it was the framing that just the swapping did. So I'm asking,
Okay.
is it always the case in every system unit?
Yes, please. It's not always the case. Even now, some current computers, they are even moving away from the processor. They are going to the electric cooling system. Are you okay with me? They are going to the electric cooling system. So we have some computers that are not implementing the using the fan method. They are using the electric cooling system. So it's not always the case that the fan will always be on top of the processor. Hello.
I think my network just cut me off. I was asking if you got me right. That is it always the case that the system unit, the CPU, is always under the fan?
No, please. That's why I also said that. I also said that now there are some current computers that are implementing what we call the liquid cooling system. So if they implement the liquid cooling system, that does not mean that the fan should always be on top of the processor. So the current, some of the current computers is not the case. So it depends on the computer. Yeah.
Exactly. I'm just asking for the benefits of the whole, because I have seen some system units that the fan is separated from there. So I'm just asking for the purpose of benefits. Thank you.
But that one is true. Then that system unit, you can find out whether it is not implemented. It is implementing what we call the liquid cooling system, which we will look at it. We look at that as in our subsequent work classes. We'll come across that some of the current computers are not implementing the fan system, and they are implementing what we call the processor and the liquid cooling system. So we'll come to that. Yes. Apart from that, any other question? Any other question? Okay, then let's move on. I think we have been able to identify. So we are saying that if you look inside the process, if you look inside the system unit, we are able to identify what we call the processor. The processor. And we are saying that the processor, from the basic knowledge that we have from the JHS, even primary school to the KG, we are saying that it is also known as what the central processing unit. That's full name. In short, we call it the CPU. And some people also regard it as what as the brain of the computer, so to speak. So the issue is somebody can also advance the argument that it is not true that we can call the processor the brain of the computer. Whilst some other writers are also saying that we can also call it the brain of the computer. Is it true that we can say that the CPU is the brain of the computer? Can we all help? Some people are advancing, they are bringing a whole lot of argument that we cannot call the CPU the brain of the computer, whilst others are also saying that we can call it the brain of the computer. Is it true? Which side will you go for? Yes.
It is
in
true,
the
sir.
class. It is true. What makes it true that is the brain of the computer?
So the processor basically does every processing in the computer. So it's just like a human being. Whatever you do, you think before you do. Otherwise, you do it wrongly. So whatever the computer is capable of doing, it is the processor that does the processes.
Others are also saying that what you are saying is not true. But when you talk of the brain, when you talk of the brain, yes, please.
Yeah, I'll also say I'll also back those who are saying it is not exactly the brain, because the processor works with other components. It is a coordinated effort that allows the processor to actually process data, and so it doesn't work in isolation.
Okay, so therefore, what would be your conclusion? Please, what would be your conclusion therefore? Hello. So yes, the processor, we are saying that others. Yes.
I
Please
still
stop.
maintain it is the brain. Even the human brain does not work in isolation. It takes a lot of things before they work. For example, you have to see or feel before your brain can think of whatever to do. So it's not only when it is about the brain, it is not even the human being, it's not only the brain that way. It does also work in isolation. So it's the same thing applies to the processor.
Okay, that's your point. Yes, who else is having a different view from what you said? Yes. Hello, are we there?
Sir.
Yes.
I also say that because of the processor that we normally get the output result of anything that we input. So without without the processor, the result that we want that we have input from the system, we will not get. So the processor deal with the output of the result of the input that we key in the system.
So
I'll go for the processor is the brain of the computer that gives us the information.
Okay. Please, do you all agree to that? We are in a class, do we all agree to what they are saying?
Yes, we do.
Are you sure? Are you sure you do? You see,
yes.
I think.
Hello, sir.
Yes, hello. Please, my dear sister, talk. We want to listen to you.
Yeah, I also want to add something.
Please add something. We are in a class, so add whatever you want to. We are learning, so please, you are free and talk.
Yeah, so I'm also saying it's the brain of the computer because I think it works with other components to be able to do its processing and then finally come out to the output. So I am of the view that no, Probably it because it coordinates with other components. That is how come maybe it's being tagged as the processor. It doesn't work alone. It works with other components to produce the output. So I also uh, have the belief, and I also agree to the fact that it's the brain of the computer. Yes.
Okay. Okay. So the issue is others who I think you are not getting me. What I'm saying, trying to say, others are saying that
I'm about to say that with the CPU, the brain thinks to take decision, but the CPU just execute a predefined instructions. So I think I also support those who says the CPU is not the brain of the, because with the brain you can choose attacks, but with the CPU, sorry, with the brain can take the, but the CPU executes a predefined task from the input section. Thank you.
the processor. Hello. Hello. Please, can you mute yourself? If you are not talking, then you kindly mute yourself for the sanity of this class. If you know you don't want to talk, once you finish talking, then you mute your microphone. Yes, please do that for me. If you want to talk, you unmute yourself and talk. After you finish talking, kindly mute your microphone so that you don't give me feedback. Okay. So yes, what we are trying to say that the processor is actually what acting like what, like the brain of the computer, but it cannot function like the human brain. We have to get to know that, because the computer is just like any ordinary device in our hands. So we human beings try to control the computer as we want to. In actual fact, the computer CPU cannot act like the brain of, like the actual human brain that the computer, the human God created. So we have to know that difference. So whatever the processor is trying to do is what is to try to behave, mimic like what like the brain of what of the human being, but it cannot do exactly what the human brain can do. So please, we have to get. Am I making myself clear? Do you understand what I'm trying to say? Hello. Yeah, so we have to know that, because yes, the computer is just like any ordinary device in our hands. And we human beings have to instruct the computer as to what to do. Other than that, the computer will just be there without doing anything. So in actual fact, it is human beings that control the computer. It's the human beings that tell the computer what to do and what not to do. So the CPU is actually what acting like what, like the brain of the computer, but it can never act like what, like the brain of the human being. So please, we have to get to know that. So they are saying the processor performs what, a limited set of calculations based on the request from what, the operating system, and it controls access to what, the system memory. And the processor is measured in what, clock cycles, in like megahertz, gigahertz, millions of what, instructions per second. So once you are using a computer, you have to know the speed of your processor. Most of the processors are measured in what, megahertz. Others are also measured in what, gigahertz, and we have MIPS, that's the millions of what, instructions. So any of this, so if you have a processor that is measured in what, megahertz, and you have a processor that is measured in what, gigahertz, which of these will give you the better output? I think the gigahertz is far better than ahead of what, the megahertz. So please, we have to know, as a hardware guy, once you have done computer hardware, you should be able to check the speed of what, your computer processor. You have to know that. Don't be a naive user, because some people are using computers. You ask them, what is the speed of your processor? Then they'll be looking at you like you have asked some question they don't know. You can just go to the properties, go to what, this PC. Once you go to this PC, then you right click on what, the hard drive. You just do a right click over there, then you go to properties. You'll get to know what the speed of what the processor that you are using. Please get to know that. Then apart from that, we are saying that if you look at the picture of the processor, can we all see, maybe some people have not seen the processor before. So we have the processor socket. I'll show you the processor socket over here. Then we have the Core i7 processor over there. Then we have the liver over there where we insert the processor. Please, can we all see it? Can we all see that picture?
Yes, sir, we can see.
Yes. So that is what we call the processor, and we have the processor socket. So when you put it over there, at some point you will learn how to install the computer processor when we can. But for today, whatever we are trying to do is try to identify the basic components. So the first thing that we do is the processor, and we have I've shown you on the motherboard where we install the processor. That's the processor socket. Then we have the ZIF, that's the socket, that's the lever over there. We call it the zero insertion force. Anytime you put the processor in the processor socket, you have to press this lever down. You just don't have to use excessive force, but you use what we call zero insertion force. That's the ZIF. You try to push it over there, you hear some K sound. You don't push it hard. Because the processor said that once you push it hard and you can score some of the pins. And even if one of the pins of the processor gets spoiled, the whole processor is gone. So please, whilst we are doing the installation, we have to make sure we put it at the right side and make sure you use the zero insertion force to install the processor. Then the next thing that we can also resolve from the list is the storage devices. And some of the various storage devices that we saw was what we saw: the floppy drives, we have the hard drive, we have the solid state drive, that's the SSDs, we have the hard drives, we have the hybrid drives, the optical drives, we have the magnetic drives, and we have the flash drives, that's the pen drives, and so on and so forth. So we were able to identify some of the storage devices. So we talk of the floppy drive. This one is what it's an obsolete technology. How many of you use floppy? How many of us use floppy? Yes.
Sir, I've used them before.
You have used some before. Then when you the papa, when you penny. Yes, who else use floppy?
Benufo,
I've also used them before.
I've also used it before.
I've also used it before.
You have also used
It's not more easy.
Because my students I'm teaching over here, most of them, they when you mention floppy drive, they can only see the picture, but they have not seen, they didn't use it. So on their money, I'm teaching for older generation. So that is a floppy drive. So now it is what? It's out of market. Then we have the hard drive. So we can we all see the picture over here? Oh, please mute your microphone. Who is this person? Mute your microphone. Please mute your microphone so that we will not get any feedback from you. So this is can we see the picture of the floppy drive? Yes, gone were those days. You just write your name and your particulars over there, and you are ready to go. When you finish working on it, then you put it in the floppy diskette, and you install your information on it. And that's what we call the floppy drive. If you have not seen it, please just look at the picture. Then we have the hard disk. So now is that we have also moved beyond the hard disk era to what we call the solid state drive. Is it true? So now most of the computers that are coming, we are not coming with the hard disks, but they're coming with what? The solid state drive. Are you okay with that?
Yes.
Yes, the solid state drive. Then we also have what we call the hybrid drive. I've shown you the picture. We have the optical drive. The optical drive is also there. We have the magnetic tape. Yes, the cassette era. Yes. I think now we are in the current technology called the pen drive, where we are all in that era. Most of us have pen drive, like it used to be in some generation where you have to also go with your floppy drive. So please, these are some of the basic storage devices that we are supposed to, and some of them, as we have already established, they are outmoded, they are out of the market. Floppy drive is out of the market. Magnetic tape drive is also out of the market. And now there are some current computers that are not even coming with optical drive. They don't have the CD-ROM. The CD drive is also getting gradually fading out. I think most of the current laptops that we have, they are coming with the solid state drive. That is the SSD, and the hard disk is also gradually fading out. So most of the current, so look at this, the pen drive. People are now using a lot of pen drive, and we are in that era. Did you all agree to whatever we are saying? Any questions so far? Any question?
Yes, sir. Sir,
Yes, please.
about the storage devices.
Okay.
I think we have primary storage device and then secondary storage device.
Yes, sir, we have it. But today I'm not teaching storage device. We are trying to identify some of the basic storage devices that we can see. So we will come back and take it one after the other and discuss it. If
I
you are
hear,
okay
sir.
with
I hear.
that.
I hear, sir.
So we are
Thank
just
you.
trying to identify the component that we can see. Then the next thing is we think that when you are dealing with storage device, once we have mentioned storage device, then we have to also mention some of the cables. We're able to mention SATA cables because we saw the SATA cables, and these SATA cables they are connected to the storage device to the motherboard. So what are some of the basic cables that we also saw in the chassis or the system unit that we opened? We made mention of the IDE cables, which we said now we call it what? Integrated drive electronics. We also have the ATA, that's the advanced technology attachment. Then we have the PATA, that's the para ATA after the arrival of the SATA. So now what we have is that the IDE is an outdated technology. It is out of market, and if you go to the market now, most of the technology that you can see is the SATA cables. Then we also have another technology called the CSI, that's the small computer system interface. Then we have the SAS, that's the serial attached distance. So these are some of the cables that you can see over there. The above belt, that's the ID, that one is out of market. Then we also have the SATA cables. That is what we are able to identify over there. Then we also have the 6, that's the CSI connectors. So this one we can find mostly at the back of the computer. And now most current laptops, they are not current desktops. They are not coming with this cable. That's the CS. They are all they are now obsolete, and most of the current laptops are not coming with, apart from the SATA cable. Most of these things they have been integrated into the motherboard, and we don't see most of these cables over there now. So that's the cables. We are saying that the SATA is usually thought of as an internal technology. That's what we always say. But there is a rising in popularity of the eSATA. We have the external SATA where we can use it as an external drive or something. So some external USB hard drive also support what we call the eSATA connectors. And we have to know that. Then the next thing that we also made mention was the memory. And once we identify what we call the memory slot. And on the memory slot, that's where we are going to put what we call the memory. So the memory is a solid state. That is no moving part, it's storage medium. It cannot take many forms such as we have the RAM, that's the random access memory. We have the flash RAM and the ROM, that's the read-only memory. Then we have the EEPROM, that is the erasable programmable ROM, and it's also there. So the access time for RAM is measured in nanoseconds. Whereas if you go to the hard disk, we are saying that the processor can be measured in megahertz, can also be measured in gigahertz. We are saying that the access time for the RAM is measured in nanoseconds. And that nanoseconds, it is known as 1 billion of a second. 1 billion of a second. 1 billion of a second. So what we say when a memory is discussed, it usually refers to the RAM, which is the computer's primary working memory. The computer's primary working memory. And so what then is the RAM? The RAM is is a form of storage. That's typically temporary storage. It's not a permanent storage, but it's temporary. So many people, as we said, might not think of RAM as a storage medium. That's what some people think. It's not a storage medium because it is volatile and it loses its information when power is removed. But temporary storage is still storage. That's what we have to know. That once we are mentioning whether it is temporary or it is permanent, what we have to know is that temporary storage is is still regarded as storage. So we have to know. So some people are advancing the argument that the RAM cannot be regarded as a storage medium. Why do they say that? They say that because they always say that they advance the argument by saying that the RAM is volatile and it loses its information when power is removed. That one is true. We all agree to that. But what we are also trying to say is that temporary what storage is so should also be regarded as what as storage, whether it is storing the information permanent or temporary. We can also regard the RAM as what as a storage what medium. So the RAM is always temporary and it requires power to retain information. Right top of the computer, that's the memory. Yeah, it's temporary. So when you put your computer into hibernation state, we are saying that the content of the RAM are written to what we call a file. The content of the RAM, they are written to what we call a file. Then it is retrieved when you power up your computer. When you power up your computer, and that content is retrieved. So where I saying the RAM is where you work with what your data and programs. The RAM is actually the place where you work with what your data and program. We have the ROM and the EEPROM memory in your computer. What it does that one it also holds the operating code for your computer. It also holds the operating code for your computer. And this operating code includes what we call the power on self-test. That's the post routine and on the motherboard level. So, and we are saying we should not get confused about the ROM operating code between the operating system, which is stored on the hard drive and runs in the RAM. So please let's get to know that very well. And in terms of the memory, too, I said the memory, the RAM chips usually reside on what we call the memory model, and they are inserted into the memory slot on the motherboard. So they have the memory model, and they are. So if you look at it, we have the memory chip. We have this type of memory chip that we see. It is regarded as on the dual inline memory model. We have the single inline memory model. We will come to that, and when we are dealing with the computer memory, we will talk about the various types. But for the purpose of this lecture and the picture that I have shown on the screen, we think that this one is regarded as the dual inline memory model. Look at the motherboard. We also have what we call the memory slot over there. Sometimes we also call it the memory bank. So please, let's get to know that if you have not seen the memory before, the computer memory before, you can use this opportunity to also identify and see that. So you said the amount of RAM necessary in the computer often depends on the types of software that you plan to use. So maybe if you are going to use something like, if you are using 2 gig or less, then we are saying that one we are using it to do some home and business uses. So if you are using the computer just for reading purpose to do some educational things, then 2 gig or less can be better for you. But if you want to also use it to do 2 gig to 8 gig, users require more advanced multimedia capabilities. Then from 8 gig upwards, then power users creating professional websites and running other 3D and designs and other things. So please, the amount of RAM that you have in your computer will help us, will tell you the exact things that are supposed to do. So if you have, so the amount of RAM that you have in your computer is very, very important. The lesser, it will not give you a lot of the, you see that the speed will not match with the hard drive, and the computer will be slow. So you can upgrade your RAM to the desired level, or depending on the applications that you are running on your computer, you have to get a RAM that suits it. Are you okay with that? So somebody will ask me, so does it therefore mean that if you increase your memory to the highest, then the computer is going to give you better speed or what? And it is also an ongoing research that you are supposed to know. Please, what do you agree? Is it true that the higher the RAM, the better the computer will perform? Is it true? Hello? Is it true that the higher the RAM, the better the computer will perform?
I think that's not entirely true. But I would like you to throw, I would like you to explain quantum computers in relation to the hardware components. If you can spend something like 3 minutes over there for us, because I think that one is purely in the curriculum. Quantum computers, its functions, and then the hardware aspect components of the quantum computers. Thank you.
No. Today we are not dealing with quantum computers. it's also a full topic that we will deal with because I don't want to mix things. Whatever we are doing today is just identification of the various components in the computer. That's the lecture, the focus of the lecture today. So I cannot shift my attention to quantum computing. Please, I'm sorry for that. But in a later date, if you want us to do that, we will do it. Are you okay with that?
Hello, sir.
Yes, are you okay with that? I said whatever we are doing is not quantum computing. We are dealing with what introduction of hardware, which we are dealing with how to identify some of the various components in the system unit. That is the topic today. So I can't shift my attention to quantum computing at the moment. Are you okay with that? We will deal with that later.
Please, you made mention that if your RAM is um, not up to the capacity that can run your program, can upgrade it. I wanted to find out whether the upgrade is it by softwares or it's about installation of certain components as well.
Oh, please, maybe you are using a computer that's having a 2 gig RAM or 4 gig RAM, but in using that, you want to also run other, you want to play FIFA game, you want to use the computer to do other sophisticated things. Then, in actual fact, what you have to do is that you have to go and buy a different RAM, maybe higher than 16 gig or more than that to suit whatever application that you want to. Then, after that, you come and install it on your motherboard. And how do you do the installation? Just go to the memory bank and remove the old memory and to try to insert the new memory that you bought. And then what do you have to do? You have to also find out the speed of the motherboard if it supports it. There are some motherboard, maybe they have say that this motherboard can also run up to maybe 8 gig RAM or it can also run higher RAM. So before you can do that, you have to read what this the information of the system to know whether this motherboard will support that RAM that you want to buy. That's all. You just want to go to the market, buy, and come and install. And when you're going to buy it, you have to know whether it is single inline, dual inline, or the type of memory that you have the motherboard will accept. I don't know if you are okay with that.
Okay, meaning there is no software that can upgrade a RAM except buying a higher one.
I want to find out from you. Do you have any software that will upgrade your RAM from 2 gig to 5?
Actually, to be honest, I don't know.
Please,
I only wanted to know.
Yeah, can somebody help him? Do we have a software that will upgrade your RAM from 2 gig to 8 gig? Can somebody help him? Do we have such a software?
So, what I know is of the mobile phones. I don't know if we have for the Windows as well, but then for the Android phone, some of them we have the extendable form of the RAM. So where you can, oh yeah, so where you can actually take part of the space from the memory or the storage device within the phone, then you add it. You take part and then add it to the RAM. So we call it an extended RAM. I think some of the phones, if you have to buy it, you see 4 gig, then they'll say +2 or +4. It means that you can extend it to 8 gig. If it is +2, it means that you can extend it to 6 gig. But I don't know of the computer.
That one, what you are saying is which means that you can buy another RAM, another memory and put it in it, or external memory and add it, or that's not what you're trying to say. Hello, sir. Hello. Hello.
Sir, my network has not been friendly to me, so pardon me, sir, please.
We are all facing the same challenge. Don't worry, Ghana and our network. So, per what you are saying, that means that you can buy another one and add it, or you use the software to upgrade. That's what we want to establish. That was his question.
No, you are not. That one. You are not buying another one. You are taking part of the ROM space, and then you add it to the RAM.
Mm-hmm.
Yes, that is how it is done.
So what he was trying to say is that in computing, we have software.
That is why I'm. that is why I was speaking in the perspective of the smartphone, and so I said I don't know whether it is also available with regards to the with the Windows operating system.
Well, I've not also seen that, but I don't know if whoever asked the question, we have we are learning, so let's try to share the content. That it can be a technology that has come, but maybe I've also not come across it. But as far as I know, if you want to upgrade your computer memory, you just go and buy the higher version and come on uninstall the older version and add the higher version. That's what I know. But for now, that's what I know. Please, are you okay with that?
Yeah. So, and just to add to some of the system units, they have multiple. Just one you showed to us that was having 4.
Having what?
Yeah, I was just adding to what you said. And I was making the point that some laptops or some system units, it also comes with multiple RAM slots. So if you are using 4 gig and you need 8 gig, you can just go and buy 4 gig instead of buying 8 gig and come and changing it. You can actually go and buy 4 gig and then you come and add it to the already 4 gig.
Yeah. Okay. So now we are going to the another component that we were able to identify what the system board, or in short, we call it what the motherboard. The motherboard. And we are saying that the term system board describes what any number of circuit boards that make up what the internals of your computer. And it is used most often to describe what we call the motherboard. And the motherboard, in short, we call it the main board in your computer. It's regarded as what the main board in your computer. That contains, mostly it contains what we call the BIOS chip. It also contains what we call the RAM. It also contains the input and output ports. And it also houses or contains what we call the CPU. We can also regard the motherboard as what as the electrical pathways that enable all other components to communicate with each other. So in actual fact, most of the components, all the components that we have, they are all connected to the motherboard. The hard drive is connected to the motherboard, and we are also saying that even the power supply itself is also connected to the motherboard, because it takes the distance from the socket. Then the power supply will convert it to a level where the motherboard will also accept. And that also will come to what the DC and the AC will come there when we are dealing with power supply. So what we have to do is that the motherboard is what we call the electrical pathways of what the computer. It houses or it contains the BIOS chip. It also contains the RAM, the input and output ports, and the CPU. And we also regard it as the main board of the computer. If you look at some other books, some other writers, they call this motherboard, some people refer to it as the main board. Other books are reading other books too, they also refer to it as the main circuit board. If you look at other books too, they also refer to the motherboard as the system board. Others also write as what as the base board. Others also regard the motherboard as the planner board or logic board. Some books also call it the colloquially, and other books also call it the AMBO or something. So these are various names, alternative names that we can get. Some various writers use. So anytime you are reading any particular book on hardware and they are referring to the motherboard as the main board or the base board, don't get confused. It's still the same motherboard that they are talking about. So if you have not seen the motherboard before, this is a picture of the motherboard. Can you all see that? Can you all see the motherboard? Can you all see the picture?
Yes, please.
Yes, so on this, what can you see? Tell me some of the things that you can see on the motherboard, some of the various components that you see. Yes. What can you see on the motherboard? This picture, based on this picture.
Sir, please, RAM memory. RAM memory
You can see
slot.
the
RAM memory slot.
Okay, that is true. Yes. What else can you also see?
The AGP slot.
The AGP slot. That one is true. Please.
The CPU socket.
The CPU socket. Yes. The CPU socket.
So please, the CMOS backup battery.
The CMOS backup battery. That one is true. What else can you see on the motherboard?
IDE connector.
IDE connector, that is true. What else?
Connections for peripheral devices.
Connection for peripheral device, that one is true. What else? What else? Yes. Oh, let me see. A CPU socket. Can we see the CPU socket? That's the where we put the processor. The CPU socket, that's the white. And we can also see what the 20-pin ATS power letter. Yes. Can't we see the motherboard? If you look at the motherboard, this motherboard is divided into every motherboard that you see on the computer. Divided into two. We have the south bridge and the north bridge. And if you look at the division, it is the AGP slot that is dividing this motherboard into two. Yeah, and every computer motherboard that you see is divided into two. We have the north bridge and the south bridge, and the AGP slot divided into two. So you come and take it and talk more extensively about the computer motherboard. That's the north bridge and the south bridge chip. Yes, please, are you okay with that? Can we all see that? Yes. So if we have the north bridge chip and we have the south bridge, okay, that's true. Then we can also see the PCI slot. That's the peripheral component interconnect. So with this motherboard, if you have a computer and it's having this motherboard, it's having what we call it the expansion slot. This motherboard, you can go and buy your TV tuner card and install the TV tuner card over there. You can use this motherboard to watch TV on your computer or on your laptop or on your desktop, because they have made available some AGP slot over there. That's the PCI slot. That's the expansion slot. You can buy TV tuner card and put it over there, and a whole lot of things that you can see there. So this is basically what we call the computer motherboard. Then the motherboard is the main circuit board of the system unit. A computer chip contains what we call an integrated circuit. So with this, we can see what we call the laptop motherboard and the desktop motherboard. What I showed you at first was what we call the desktop motherboard, and this one is what the down one is what we call the laptop motherboard, and it follows the same process, but then that the desktop motherboard is more heavier than the laptop motherboard. So please, let's get to know that we have to know what we call the motherboard and some of the various components on the motherboard. That's true. Then we have other systems also called, they also have what we call the daughter board. There are some motherboards, sometimes we refer to them as daughter board. The daughter board is what is a secondary board that contains motherboard functions, such as what the input and output control. The daughter board is what is a secondary board that contains the motherboard functions, such as the input and output control. So the daughter board is also a board that contains some of the chips that could have been put on the motherboard, but were not. So perhaps because of space limitation or for other reasons. So it is common to see them use laptops and other mobile devices. So we can see a motherboard with what? With a daughter board. So these are some of the daughter boards that we have. So sometimes we have a motherboard and you go and buy some component like the TV card, and the TV card is also having another board in it. But now that board takes its sources from the motherboard. So we will regard that board as what we call the daughter board, and so on and so on. Then we also have what we call the power supply. That's the power supply. The power supply does exactly what its name suggests. And what does it suggest? It supplies power to the rest of the components on the motherboard. So the power supply supply power to the rest of the components on the motherboard. And the power supply takes what we call 120 to 240 volts, depending on the country where you are, where you reside in, of what alternating current, that is the AC from your electrical outlet, and it converts it to what? To other 3.3B or 5B or 12B of what? Direct current. So that is the basic functions of the power supply. It takes what? Power from the alternating current, and it converts them to the direct current. And you're saying the power supply, it contains a number of what? The number of leads that supply different voltage for different types of devices. such as the hard drive, the PCI, and so let's see. This is what we call a typical power supply. Can we see the picture over there of what a desktop? This is a typical power supply of the desktop. So the power supply converts the wall outlet. It always takes from the wall outlet, and that is what we call the AC. That's the alternating of current, and it converts it into what we call DC. That's the direct current, and the direct current is what we call that's what the motherboard can work on. The motherboard cannot work on the AC. And if the power supply fails to convert it from AC to the direct current, then what happens? Like it will blow your motherboard, or sometimes the power supply will be blown. So please get to know that sometimes what you see that the motherboard is blown. The power supply will convert from AC to direct current, and it will blow the motherboard. And sometimes what you see that the motherboard is gone forever. You can repair it. And at other times, if the source from the electrical, the wall outlet is too heavy and the power supply is very good, the power supply will also be blown up. Say a show power supply, I say, or something. So we have to put in what it does is convert the wall outlet, that's the AC, into what we call the DC. Some external peripherals also have what an ACR adapter, which is what an external power supply or something. So we have what we call the adapter cards. The adapter cards. The adapter cards allows you to adapt your computer to another role, such as controlling assembly line robots or specific component to your computer. So the most common adapters are now integrated into most motherboards. So most of the common adapters that we have, we see that they are integrated into what for the motherboard. These components include what for the display, the network keyboard, controller, the mouse controller, the serial port, the power port, the firewall port, and the USB port. So some of the adapter cards, adapter slots that we have the ISA, we have the PCI, we have the PCI Express, and we have the AGP. So these are some of the pictures that we can see. We have the AGP slots, we have the PCI Express, we have ISA, that's the integrated functions, and then we have the PCI, that's the peripheral component interconnect. When were those days you connect your computer or desktop, or if you want to use it to browse, connect the internet, you have to get the network and go install it on the motherboard. But now we are seeing that most of these adapters that we are talking about, we have integrated them directly onto the motherboard. Now you don't need to go and buy this external adapter cards. Most of the desktops or the laptop that we have integrated the network adapter directly onto the motherboard, where you don't need just slot you are taking over there and you are ready to route. So that is the ATP slot, the PCI. So most adapter cards, what you have to know is that we have integrated them onto the motherboard. And so we also have the expansion slot and adapter card. So an expansion slot is a socket on the motherboard that can hold an adapter card. So an adapter card enhances the function of the component of the system unit and provides connection to the peripherals. So we have to get to know that. So what's the expansion slot? Most of the expansion slots that we used to have, we see that they were plug and play. Once you put the plug and play, you put it on the computer will detect it automatically and it will do the installation. For that, the computer automatically configure the adapter class and add peripherals as you install them. Even this one, when I was being at 33, I was using my laptop to watch TV. What I did was to go and buy what was the TV tuner card. So when I came, what I did was I opened my desktop and go to the expansion slot. I installed the PC tuner card onto the expansion slot. After that, I just played the system unit. Once I put it on, the computer was able to detect the TV tuner card automatically. Then I did some basic information on it. After that, I was able to use my report. So that's what the adapter card. And some of these adapter cards, we have what we call the network adapter card. We have the modem, the MDI, connects musical instruments. We have the cable card, allows. We have the disk, we have the fireware. We have the USB. We have the video. We have the video capture, the TV tuner. We have the sound card, and so on and so forth. We have the PC TV, and so they are adapter cards that what we are trying to say that most of these adapter cards that we are talking about, we have integrated most of them on what onto the motherboard, and we don't need to buy that. Please, are we okay with that? Any question? Any, no, any question? Any question? Okay. Hello, are you there?
Yes,
Yes,
sir,
sir.
we
Yes,
are here.
sir.
Okay.
Yes, sir.
We are moving on to what we call the cooling systems and the fan. The cooling systems and the fan. We're able to identify the cooling system and the fan. So as to remove heat from the computer system, what we that there has been what a steady increase in the use of fans, the vents, and other heat dissipation units. So what happens that the heat sinks with fans are commonly placed on the processor and what the critical chipset. So the processor generates a lot of heat. So that's why we always have the fan sitting on top of what the processor too. And that the heat sinks are made up of what we call heat conductive metals. And we know that usually these heat conductive metals, they are of what? Aluminium or copper. Why do we always have wherever we have the heat sink, this thing is made up of what we call the aluminium or copper? Why? Who can give me a better reason for that? Even the cooking utensils that we have in our house, we use aluminium and other things to it. Why? Yes, you can answer that question for us. Oh, okay. Because aluminium is what? It's a good conductor of what? Heat. It's a good conductor of heat. Because they are a solid side in contact with the chip. They are protected and this and fans on the other side. So that's putting greater surface area or something. So that aluminum is what is a good conductor. That's all. That's the point that we're trying to see. So if you look at this, you can see that the processor is down there. And then we have the fan on it, and on the fan you see that we have this plastic this on the fan, and the rest is made up of what we call the aluminium or copper. Why do we have the aluminium or copper again? Because we are saying that we have the aluminium there because aluminium is a good conductor of heat, a good conductor of heat. And beneath it, you have what we call the processor. Because the processor generates a lot of heat, so we need to use the fan to cool it. And beneath the fan or the plastic, we have what we call the aluminium, or the reason being that it is what it will put on that of heat. The use of fan with heat sink allows more air to flow through the things. So the case vents and the fans bring what we call cool air into the computer. So the faster processors produce more heat. Faster processors produce more heat. So as the processor have become faster, more of pulling the heat away from the processor will also develop. So now most of the computers, as we said, they are not coming with what we call the fan and those things because the fan generates a lot of what. It's sometimes if the fan is hot, it makes the computer generate some noise. While the computer is processing, you hear a lot of noise. So we have moved from the fan stage to what we call the liquid cooling system. The liquid cooling system. So when we talk of liquid cooling system, what is it? It's a new technology that most computers are now implementing. Most of the current desktops and the laptops that we have, they come with what we call the liquid cooling system. And the liquid cooling system is the reduction of what heat and temperature of what the inner environment through what exploiting the properties of what liquid. So liquid cooled machines maintain some desired operating temperatures environment better than what they are air cooled ones. They are air cooled ones. So what are some of the advantages of what liquid cooling system? Liquid cooling system is what? It's an efficient system of what? Mitigating heat away from the processor and outside of the system. Consequently, what happens that this allows for higher speeds in the processor. Another advantage of the liquid cooling system is the reduction of noise. So that's why sometimes if your processor or the fan is faulty, you hear a lot of noise. But most of the liquid cooled machines, sometimes if the computer is even running, you will not even hear some. You will not hear, not get to hear any noise. So most of the combination of heat sink and fan generate a lot of noise because the fans usually have to what circulate a larger volume of air over the processor at a higher speed and through the system. So liquid cooling eventually what requires much less space and also gives what a good performance as well. If you are using the liquid cooling computers or that one, you see that it requires what lesser space. Whereas if you are using the fan and the distance, it requires a lot of space. So we have what we call the firmware and the chipset. The firmware and the chipset. Yes, the firmware fills in the middle between what the software and the hardware, where the different light things what disappear. So firmware is what is programming code or software that is contained or stored on the IC, that's integrated circuit of chips on your computer. So this combination of hardware and software makes up what we call the BIOS. The BIOS, that's the basic output system on several different devices. Respectively, in the Siemens or the flash form. So what happens is that the compatibility of these chips and the code that ties them together is provided by what a single supplier and all this. We have Intel and what EIA technology produce what popular some of these popular chips. And so we have what we call the firmware chips, and you can see the picture on the motherboard. I've captured it for you to see, and that's what we call the firmware chip for you to see. Then we have what we call the BIOS. The BIOS. The BIOS is the basic input-output system. The BIOS is actually what a software that is stored on the ROM chip on the motherboard. It's a software that is stored on the ROM chip on the motherboard. Most systems today use what we call the flash EEPROM to store the BIOS so that the user cannot update the programming code in the BIOS. When were those days, if you have a computer, you cannot update the BIOS. But now, the current technologies, the current computers that are coming, you can update your BIOS because they are using what we call the flash EEPROM. And you can go online and download the code and the software and come and upgrade what your BIOS. But when were those days, it becomes very difficult to upgrade the BIOS. But now it's not the case. So the first program or set of instructions that run when the computer is switched on is what we call the BIOS. Anytime you put your computer on, the first set of instructions that is you will see is what we call the BIOS. So the BIOS is responsible for controlling or managing low-level but extremely important process like what we call the POST. That's the power on self-test, the boot process, and the interaction of what components on the motherboard. So you have to know that the BIOS is responsible for controlling or managing the low level, but what extremely important process like the POST. Front of the POST is what power on self-test. Anytime you put your computer on, once you press the power button, the computer will check to see whether the monitor is correctly connected to the motherboard. It will also check to see whether the keyboard is correctly connected to. It will also check if the memory is well seated in the memory model. It will also check to see if all other components are well connected to the system. Before you hear some sound, after that you will see what you call the operating system will start loading. But if the computer check all these components and see that one is not even working, then the computer is going to fail what you call the booting process. The post will fail. Once the post fails, the computer will not be able to put, you will not see the operating system, and you have to go and back and check and ensure whether the memory is well seated, whether the keyboard is well connected, whether the monitor is also working very well. So please, you have to know the difference very well. So in actual fact, what you are saying that the BIOS is what is the interaction of components on the motherboard is checked to see whether all the components are well connected to the motherboard. That's that for you. So that's what we call the BIOS. It's also on the motherboard for you to see. There's a motherboard. They have what they've labeled it for you to see. That's the BIOS chip. That's the basic input and output system. Any question so far? Please, any question? Any question?
Yes, sir. So I've seen, I don't know, my network. Okay, so I think I saw EEPROM. I think I didn't hear what you talked. you said concerning the EEPROM, if you can.
I said the flash EEPROM, and we are saying that it's a new this thing. One with those days, if you have your BIOS, you couldn't update your BIOS. I said something about that. But currently, we have what we call the flash EEPROM, where most of the systems allows you to go back and you can update the BIOS, and that's the current technology. That's what we call the flash EEPROM, to store the BIOS so that you can update the programming code on the BIOS. That's what I said about it. Hello, are you okay with that?
Yeah.
So get to know that. Please, you will see a lot of questions. You see some questions in some of this. So please understand what the BIOS is. When you mention the BIOS, you have to also understand what we call the post. But today, whatever I'm doing, we are just doing some identification. We talk extensively about most of these things. When we talk of the post, what is the post? That's the power on self-test. I'll take my time and explain those things for you to see. And even before I explain, you should know that any computer that you put on have to go through what we call the post. Once the computer fails the post, the computer will not put for you to see the operating system. So you have to. And once the computer finishes the post, you will hear some sound. Once you hear that sound, then you see that the operating system will start loading for you to see or it on the screen. I know most of you know these things already. So once it fails, you will not see it. And if it starts, it will start low. If you start loading it, you see hear some sound and all those things. Okay, let me move on to the UEFI. The UEFI. UEFI stands for what we call Unified Extensible Firmware Interface. Unified Extensible Firmware Interface. That one, it represents the next generation of what the low-level run-based code. So the UEFI, that's the UEFI, is capable of what supporting advanced diagnostic tools, even without having an OS installed on the computer. The UEFI supports network booting. It also supports what we call secure boot, and even has a limited shell for running the commands. So this is what we call, if you don't understand, we have the BIOS, that is the blue screen, and we have the current one, that's the UEFI. Have you seen this that we are talking about? Now, most of the computers that we have, they are using the UEFI instead of what the BIOS. Hello, are we there?
Yes, sir.
Am I making some sense? Have you seen the BIOS and the UEFI? So the BIOS is the old technology, and that's the blue screen. But now we have moved from the blue screen to what we call the UEFI. That's the new technology. And most of the laptops or the desks that are coming, or the recent ones, they are not using the BIOS, but they are rather using what we call the UEFI. Are you okay with that? Okay, fine. So when we talk of the BIOS, I think that one is the blue screen that resembles what the BSOD, and the UEFI is what is user friendly and graphical user interface. So the UEFI, that one is more user friendly, and it's also having what we call the graphical user interface, whereas the BIOS is not having. The BIOS cannot recognize larger storage device, whereas the UEFI can recognize what we call larger storage device. And we are saying the BIOS is only able to use keyboard. So if you go to the blue screen, you can only use the keyboard to control and navigate throughout. But the UEFI, that one allows you to use what we call the mouse. It allows you to use the mouse in the interface. So there are differences. So, and the current technology is what we call the UEFI. The BIOS is now an obsolete technology in most of the desktops and the laptops that we have. They are not coming with the BIOS, but they are rather coming with what the UEFI. And any question on that? Please, any question on that? Any question? Are you okay? Can we move on?
Yes, sir. We can move on.
Okay, so there's no question so far. Okay.
Sir.
Yeah. Yes.
So if I understand you well, the BIOS, the UEFI is more or less an advanced form of the BIOS.
Yes, sir. Yes.
So it also tests the basic input and output services before the computer turns off.
Yeah.
Thanks, one. Okay.
Yeah. And
Thank
now
you.
the blue screen is true. The blue screen is now out of market. Most of the laptops or the desktop that we see, they are not coming with the blue screen. No. It's now out of the market. What we have now is the UEFI. Okay. So the next component that we can also identify, or that we were able to identify, was the CMOS. The CMOS. That's for short. But if you want to put it in full, we have the complementary metal oxide semiconductor. That one is, I think that mostly some students confuse it with what the BIOS or the UEFI. But what you have to know is that the BIOS or the UEFI is a programming code that is stored on a ROM and the EEPROM chip. And what it does, that it controls the leading of the operating system, as well as the low level functions. So the BIOS and the UEFI often has settings that the user may control, and these settings are stored in what you call the CMOS memory. The CMOS memory, where the CMOS refers to the type of manufacturing process that creates integrated circuit and most other things. So the most RAM chips rely on the CMOS technology to store information. Most RAM chips rely on the CMOS technology to store information. But when discussing the CMOS, we will referring to the hardware computation settings that are saved between the input of your computer. So we have to remember that the BIOS and the UEFI store the programming code, whereas the CMOS stores the setting for the BIOS and the UEFI options. Other important data that is kept in the CMOS memory is the time and date, which is updated by what we call the real-time clock. That's the RTC. So anytime you see that you set your date and time, when you put your computer off and you turn it on again, the date and time will set to a different date and time. Then you have to know that there's a problem with your CMOS battery. You have to change your CMOS battery. It is gradually it is dead, or the power is now less or something. So you have to change it. So that is the CMOS control the date and time, and that one is always updated by the real time clock. That's the RTC. So if you have not seen the CMOS battery before, this is it. It's like the ordinary wristwatch battery, the battery that we see. If you have the calculator and put the battery out, you will see that that's the CMOS battery. Can you all see that it's also on the motherboard? Can you all see it? So that is that for you. Then we have done any question. You have some question. If you have some question, you can ask. Why? You want to talk, or who is that person? Please mute your microphone. Mute your microphone. Please mute your. Okay. We are going to check.
Olazi, Papa, please use the microphone for us.
Okay, so we are going to check outside the box. That's the outside the system unit. We have looked inside the box. We talk extensively about some of the distance. So if you look outside the box, what else can you see? So now that we have looked what's inside, hello, please talk. I'm listening.
Sorry, my network was this, so sorry to drag you back. I have
Don't
a
worry.
question to ask. At times you boot on your system and then the BIOS will pop up. You try your possible best to make sure you clear it off. Yet they'll still be telling you, even some cases they'll be asking your password. So you don't also know who.
You said the BIOS will do what? Hello.
I think he's having a network challenge.
Hello.
Yes.
Please, I don't know whether you've gotten my question right.
No, I didn't get it right.
I'm saying at times you boot on your your system, your machine, and then the BIOS will pop up asking you to do what was set up. So some cases they'll be demanding some password before you'll be able to clear it off. And I don't know where from that password to. So I want to find out what normally led to the BIOS popping up without, disappearing by itself again until certain
What
settings
is
are
the,
being made.
are you sure? Please, who can help him? Who can help him? Who can help
Hello,
him?
sir.
Yes.
So I want to answer for the password. If
Okay.
the BIOS is asking for a password, it means the laptop is not yours.
Okay.
Yes, because if, like, for example, my laptop, I can put password on the BIOS so that when somebody takes it, the person has to insert the password before the machine will boot.
Okay.
Okay, so if it was me, then I know the password. I will just enter it.
Okay.
Yes, so the machine was not for him. Thank you.
So sometimes you have second-hand laptops too, and they do
Okay.
that.
The second-hand laptops can do what? Please, we are learning. You said sometimes what happens?
Yeah, I was saying maybe you can buy a laptop from someone, and maybe the person have put in that thing on it or the password on it already. Most second-hand laptops, some of them, it also pops us with those passwords. And since, as he's saying, you're not the first person who uses it.
So what can you take the password of the BIOS?
As
Hello.
my brother was saying, sometimes
No,
not
you
that
you
easy
can't.
to keep it up.
You just need to do what?
You just need to call the person, and then the person will give you the password.
Okay, so if you put the password on the BIOS and you put the password on the operating system, which one is more secure?
Okay.
Hello.
Is
Yes.
it my question, please?
Yes. Anybody can
Hey.
answer.
Okay, so let me try this. I think for security reasons, okay, for if you put password on the BIOS, it's not easy for a person to be able to enter your machine. All right. Hello.
Yeah, we are listening to you.
Yes. So I think if you want a secured laptop, then the password must be on the BIOS. Now that the BIOS is even moving out, so UEF something something. There is there's password. You put password on it. Thank you.
Okay. Yes. Okay, fine. So let's move on to the checking outside the box. Outside the box, that's the system unit. So if you take the system unit, what are some of the things that we can see outside the box? And let's see some of the things that they are let me see. So we have what we call the form factor. So the form factor refers to the size of objects. So when you take any system unit or any motherboard or anything, you have what we call the form factor. Once you have your computer, you see the form factor of the computer. Every human being too is having a form factor. If you take any object, it's having what we call a form factor. So you see the form factor refers to what the size of the object, be it the hard drive or motherboard or the case. And many objects have industrial specifications that define acceptable or allowed sizes. Please kindly mute your microphone. Who is kindly mute your microphone? Who is this person? Mute your microphone.
Naomi, please help us mute your microphone for us, please.
Okay, thank you very much. So we are saying that when you talk of form factor, any laptop that you see, you can see some laptop that is big, others small in size, others sizable. So once you see it, if it is big, that is the form factor. If it is small, so that is the form factor. So the form factor refers to what the size of what any object. So motherboard and hard drives, they have what the industry-wide specifications. Yet computer cases do not have specification on their size or shape. So computer cases do not adhere to what the specification of what the internal system. So let's see that. So some of the input and output devices that we can see at the back of what the so computers use different kinds of what input and output device. And one of them is the monitor. So the different types of what buses that can provide video service include what the monitor is one of the basic or output device. And we have the peripheral component that connect with it and all those things over there. We have the PCI and the APU slots and others. So we can see some of these slots at the back of what of the this thing of the motherboard. Then we also have what we call the modem. The modem is also in short for data data. It refers to what the conversion of what the data signal towards an analog signal and the modulation services. And so please, as a modem, you know it. And standard modems connect to your computer through what we call serial port. They can either be synchronous or asynchronous. When you say that it is synchronous, then it is kept in synchronization by an external clock. And if it is asynchronous, it is also kept in synchronization by control signals in the transmission. So most modern that are features for computer are what asynchronous. That's one. And we also have what we call the ports. The ports. On the back of this thing, we also see the ports. So the ports are connection points for cables, which allow for transfer of data between your computer and other devices. So several different types of connectors and cables are used to join devices. So what are these ports? They are serial ports. We have the parallel port. We have the video port. So the serial port connects serial devices such as what modems to your computer, and the parallel port connects parallel devices such as what printers to your computer. Then we also have the video port. It connects monitor to your computer. So this is what we call the serial ports. Now some of these ports, they are all running away. They moved out of market. We have the parallel port. We have the game port. We have the PS2 port. Except the PS2 port, it's no more in the market. The game ports, gradually they are all fading out. Like all these ports, they have been replaced by USB. Most of these ports that we see, they have been entirely replaced by what? USB. So the USB port connects so if you have the keyboard, it's now using USB. The mouse ports, they are all using USB port. If you look at the back of the listing, you can see a lot of what these ports that we can talking about. We have the microphone port, we have what we call the keyboard port, we have the mouse port, we have the network port, the audio in and audio input, and so on and so forth. We have the network port, the mouse for the digital audio, and so on and so forth. The HDMI port, and as video port, and so on and so forth. So these are some of the ports and connectors that you can see at the back of what was your assisted unit. And sometimes at the front page too, you can also see the microphone port, you can also see the headphone port, you can also see the USB port, and so on and so forth. So please, let's some of these things, we know it already. So the ports and connectors, we have the audio in, the cable TV, the HDMI port, and these are some of the ports that we were able to identify, and you can see them at the back. Any question so far? I think I've done for today's lecture. We are able to identify that. So we are going to end here. Next week we will continue. Any questions so far?
That's right.
Please, any question? I'm tired already. I'm very tired.
Hello, sir. Hello. Sir, please, I wanted to ask about the CMOS. Apart from the CMOS memory and then the CMOS battery, do you have another CMOS for other tasks?
Other CMOS, like other tasks like what?
I'm just, I don't know.
Me too, I don't know. You have to know the task that you're talking. Other tasks like other tasks like maybe mention some of the tasks that you want to talk about.
Okay. Then maybe I'll go and make research about that. Thank you.
please, today, whatever we did today is to identify most of the basic components that we see in this when we open the system unit, and also when we also come to the outside the system unit. And I think I have done you good by trying to identify most of the basic components. So in the subsequent lectures, we are going to pick the components one after the other, and we will talk extensively. We will digest it and talk more about it. So maybe in our next lecture, I think we are going to take the processor. Everything that we will talk about is the processor. So so I'm going to send the materials, the course outline, the PowerPoint slides, and everything to the course rep, and the course rep will share it with all of you. So please kindly get it, and it will help you. Okay, all the best. Thank you for joining. Next week, when are we making?
I think same day.
Yeah, please.
Same
Same
The same time. Okay. If there will be any changes, I'll communicate to the course rep. I think next week by this time I might not be in Cape Coast, but wherever I am, if I'll be able to make it, I will let you know. So don't worry at all. I'll communicate to the course rep. Whatever be the case, you'll get to know when we are. Okay. So bye bye.
Yes. Thank you for your time, sir. Thank you. We are grateful.
I'm also
Thank
grateful. Thank you for joining. I'm very happy. All the best. Bye bye to all of you.
Bye.
Go and get some fufu, apple, and banku to eat and sleep. We are tired already. Yeah, bye bye.
Bye bye.
Bye.
Sir, please can you have your
God
cell number?
bye.
Yeah, you can,
Once
you
you
can
have
ask your question.
contact, sir, and take
You can
the
ask your question.
material.
You said what? I will send it to the
Can you
course rep. I will send it to the course rep.
Thank you, sir.
please and your contact?
Sir, bye.
This call has to
My
open our
contact
source. Open our
Yes.
computer very short.
when you get the course out, my contact is on it, so I'll put the course.
Okay. Okay. Thank you.
Bye bye. All the best.
Bye.
Bye.
And you use it, Charlie.
Go and eat banku, apple, and sleep. Don't learn. We get F plus. Charlie. Suffering upon suffering.